So what is data engineering? So generally, many of you know about the recent increase in the size and volume of the data. So to embed that data into the infrastructure or utilize that data, we need to process that data. So like uh, consider for everything we are discussing, we will be considering it in an organization. So let's take one organization, any of the organization as an example. If there is an incoming data, let's take Facebook. So it will be having lots of ads. It will be collecting huge data from users, whether it can be mobile or whether it can be a tab or a laptop or a system, wherever it might be. So Facebook is collecting a huge data. So that data they will be using it for ad revenue. Uh, so they will be suggesting some products to the users, some ads, recommended ads, all these stuff they will be doing. Right? So to do that, they need to collect data, process that, analyze that, all the stuff they need to do. So while uh, they collect the data, the Facebook collects the data to process that, build that, and analyze that. What particular role will be there? The data engineers will be there who will be going to process the raw data, clean it or whatever it takes. So they process the data, they build uh, uh, data models for that and analyze the data. Once they analyze it, the end customers will be using it. So they collected some personal data or whatever data from the mobiles. They process it, build it based on my data. They will be suggesting some ads. So they will build the data model. They will analyze that data and they will be displaying ads for them. So that's how Facebook is process building, doing the data engineering part and display. So in similar way, there are many organizations where they wanted to when they are collecting data or getting the raw data, processing it, doing the data modeling, and then uh, analyzing it and suggesting the and making it available for the customers to utilize. So in earlier days, it was traditional. It is in the traditional way, we'll be having some traditional on-premise SQL servers, Oracle servers, or MySQL. There will be relational databases. So in relational databases, it will be um, direct, like we'll be having our own dedicated servers. The data will be stored in that server, process, building, and analysis. All these will be stored in that relational database. But uh, when the data's volume is increasing, so let's say take Facebook as an example again. So in the initial days, users are very much less. So the incoming data is very less. The traditional on-prem SQL server or Oracle server or Postgres, they are sufficient to do the data engineering part. But later on, usage of internet increased, mobile devices or the devices using the internet increased. Lot of things change. So the data volume has increased. So they need a bigger system to uh, they need a bigger system to process that data or to store that data, to analyze that, to build the models, everything. So to do that, uh, big data came into picture. So the difference between big data and traditional relational databases is the way of the data distribution and process. So generally, um, in a relational database, we'll be having our dedicated servers, fixed memory, and everything. but the processing will be on same nodes. But in big data, the parallel processing will happen. So it will be a distributed system and parallel processing will happen. So the advantage is of big data is, so we'll be having, it will be handling huge data. It will be easy to make decisions faster. It will be processing, parallel processing, and it will take less time to process a job or to process a data model. And it will be like, if it is processing a little bit faster, uh, the analytics will be somewhat real time. So some if the relational database is taking 1 hour, if we are doing it in a parallel way, it might take only 5 minutes or 10 minutes. So that way, it will be it will that way the big data comes into it. Sorry, big data is replacing traditional. So to overcome all these issues like storage cost, management, data management complexity, infrastructure, processing speed, data integration, security. So all these things will be handled for uh, huge data sets. So if we have a huge data set, obviously we need to have more storage, more network bandwidth will be utilized, more energy will be consumed, and we need more security. So um, we need the data integration will be complicated, and even processing speed will also be increased. So to overcome all these challenges, we will be using big data. So to build to utilize to use this big data or to use AWS cloud, we have few roles available. So like there are data engineers, there are data scientists, there are data analysts, and yeah, there are database administrators and others, data architects. All these um, persons will be there in an organization. So basically, the data engineers will do whatever we are discussing so far, like data pipeline building, data integration, infrastructure management, database designing, data modeling, security implementation, quality establishment, and performance optimization. All these are the responsibilities for data engineers. And coming to data scientists, so whatever data engineers are doing, like the process and building, once the data is processed and built, there will be two ways that they are using the processed data. So whatever data engineers process, either data analyst or data scientist will be utilized. So in data scientist will utilize that data to predict things for machine learning or data visualization, modeling, analysis, all these. So the data will be going two ways. So for the best example for the data scientist is weather forecasting. So generally, um, when we get weather data from the satellite or weather recording center, the data engineers will build the data models of everything. So cleaning and all they will do, and then the data scientists come into picture. They will predict how, based on the previous data or the process data, they will predict how weather is going to be for next 1 day or 1 week or 1 month. So that that goes in that way. So we have one more role where they are utilizing data analysts, where they are utilizing the data processed by data engineers. So the example for this one is sales data. So an organization is having sales data and financial data. Data engineer does the again the processing part, and then once the data is in place in the data warehouse, data analysts will analyze that, query that, retrieve that, build some charts, visualization, Tableau or QuickSight or Power BI, whatever, wherever it is, and generate reports for auditing purpose or to, like there will be like board meetings, right? So they will be doing some reports for it for customers or the management or whatever, whomever it requires. So they will be generating the report. So sometimes data engineer will do what data analyst is doing. So that's the different scenario when a data engineer is also acting as a data analyst. He will be doing the data analysis part as well. But it's in bigger organizations, everyone will have their own role. So data engineers will be separate, data analysts will be separate, data scientists will be separate. So, and we have a few more roles related to this data. So database administrator who is going to manage database, business intelligence analyst, so intelligence analyst who is again doing the similar work like a data analysis, um, and business architect, sorry, data architect. So he will be doing some data modeling. So how he wanted the data, how he want the data to be look like, all these things, and data quality analyst. So he will be testing out how the data is and whether it is in correct format, correct values are populating. All these testing part, kind of say like testing part. I'm taking it as note. So cloud services. So generally, when we are talking about big data, uh, we have three ways of data processing. One is the traditional way, the next one is big data, and the next one is cloud service. So on traditional on-prem relational databases, we'll be having our dedicated CPUs or dedicated servers, everything. And then when we wanted to process huge data, big data comes into picture. Even for big data as well, we will be required a huge servers with huge configurations like more memory, more number of cores, nodes, everything to submit our big data jobs. So, in order to run that big data jobs, we need to manage servers on our own. We need to purchase our server or rent our server. We need to um, create the infrastructure for that server. We need to configure it like for each job. We need to configure it, configure the clusters, and we need to maintain that server, everything. And the accessibility for that server will be limited unless we need to create some secure network and grant access to use it anywhere we want. So there will be some security concerns and there is some maintenance and efforts needed. And also, once the server is configured, we cannot increase that server configuration. Let's say I have a server with memory configuration of 2 TB. So that 2 TB configuration is so as the data increase, that 2 TB configuration is not sufficient for to run my jobs. I might need one more TB of data, sorry, one more TB of memory. So in order to increase that, again, maintenance is needed, or I need to replace my servers, or I need to purchase new server. So there are things that taking going beyond our hand. Like we need to keep more efforts to uh, maintain the infrastructure to process the big data. So, in order to rectify that, in order to reduce that maintenance and all, cloud services comes into picture. So, what is cloud service? Cloud service. is again similar to whatever we are doing with the big data infrastructure. It is similar to that, but the only difference is servers are maintained by AWS or respective cloud provider. Let's take AWS as an example. AWS will be having their own servers at different locations. They will be placing it there. They will be maintaining it there. They will be providing us access to us to end users, whoever using that wanted to use that cloud server. They will grant access to that cloud server. So inside that cloud server, there will be services available. So to run the big data jobs, or to run the Python jobs, or to run SQL instances, they will be having their own services. They created their own services. They hosted it on there. So once we are logging into that server, if we have access to the respective services, we can pay them and utilize them. So here the major advantage of using the cloud services, we whenever we want more configuration for a service or for a cluster, we can increase it. So we will be having the flexibility for the resource allocation. Um, so earlier we need to buy our dedicated server. Now we can just rent out the server, like whatever the portion I am using, I can pay for that one. I can have my own services, whatever the services I am using. I want, I can use only them. And also storage, I can increase my storage or only decrease my storage. I mean, how much, whatever my requirement, I can only choose that. And also maintenance cost is very much less. So maintenance part will be taken care by AWS itself. So there will be less maintenance for it, and also security. AWS is providing its own security. So all we need to do is we just need to utilize that security properly. So if you use that, there is no need to add additional security measures and all. And we can access these cloud services anywhere in the world. So it is like easy accessible, easy to access anywhere from browser in the world. And data management architectures, we have two types of data management architectures. One is the traditional architecture, and the other one is modern data lake architecture. Traditional architecture is nothing but we'll be having database tables, dimension tables, path tables, and or maybe we'll be having tables in SQL Server or Oracle, PostgreSQL, anywhere. And modern data lake architecture is we'll be having tables in file system. So it will be like Apache Hudi, Apache Iceberg tables. So the data will be stored in file system, but we'll be having tables on top of those files. So that is an upcoming, like currently existing, but the future will be like it will be mostly as the data is increasing, as we are getting huge data. Everyone wanted to have the historical data, and the storage in the databases. Maintaining the databases is becoming little bit hectic. So everyone is opting to have data lake architecture. So uh, we will be having a file system like S3, AWS S3, and we'll be creating a Hoodie table or iceberg table, and we'll be creating tables on that. So it will be similar to the tables in database system, but the data will here the data, instead of storing it in the database, the data will be stored in file system. Um, any questions? Any doubts?
No, Sri.
Okay. Yeah. So, coming to AWS part, we have different services available in for different processes. Like for uh, as, uh, we will be getting data from different applications. So we need ingestion services. And once the data is ingested into AWS cloud, we need process. We need to process that data. We have processing services, and then once we set up all the ingestions and processing services, we need to orchestrate all of them. So we have few services for orchestration, and then uh, once the data is processed and scheduled to process, we need to analyze that data or utilize that data. We have some services to utilization. So these are all the services for database, sorry, data ingestion, like database migration service, dynamic service cluster, app flow, transfer family, data sync, and snow family. So these are to migrate data in real time. That DMS and Kinesis will be like streaming data from source to target, like from SQL Server to S3 or other database to S3 in real time. Even MSK is managed system for Kafka. So if anyone heard about Kafka, you might have known what why we are using Kafka and all in the existing system. So here AWS provides support for Kafka. So Kafka is a streaming service that will read messages from source and write to flow, transfer family, data sync. All these will be reading data from source, from different kinds of source like SFTP server, database, SQL database, or SaaS applications, so whatever we are configuring. It will read data from the source and write it to uh, target, whether it can be another database or a file system or somewhere unit. So we are going to discuss all these services in depth once we start uh, starting on AWS Cloud. So the processing services are Lambda, Glue, and EMR. So Lambda is serverless, Glue is serverless, and like EMR is like server. So we need to maintain that, create the clusters in the server and configuration, and we need to run the big data jobs or even Python jobs in here. So each one will be having its own advantages and disadvantages. And the pipeline orchestration is, so once we created all our jobs in EMR, Glue, or Lambda, we need to orchestrate them. We need to schedule them. We need to create the dependencies between the jobs. So for that, we have workflows, step functions, Apache. We can use any of these to run our um, data jobs. So once the data is orchestrated, once the pipeline is running every day, uh, the data will be processed and made available for the end user. So how the end user will be utilized, whether it can be data analyst or end customer, they might be querying that data or they might be building some uh, reports on that. So even AWS is providing a few services like a QuickSight to build um, charts and all. And to query the data, AWS provides Redshift Spectrum, Athena, and there are a few other services where we can maintain our own data warehouse. So these are the services where we can utilize data in AWS service. So again, we have few more concepts like encryption, access control, data masking, and monitoring. So even though we are moving our data on the network from existing on-prem server to cloud service, we need to encrypt that. We need to encrypt that network, and then we need to control the access. for all the users in that cloud. Uh, only not if we have 100 users having access to AWS cloud, we cannot grant access for 100 users to access the data. So we need that level of access control, like IAM roles, users that comes into picture. We need to manage access for each user. So some users should only access the end, like Redshift and Athena. Some users only should have access to set up the EMR cluster or EC2 instance. Some user might only should only get access to build glue jobs, and also so that every user will not see the entire data. So that level of access control we need to create, and data masking. So even though most of the users will be having access to data, everyone should not see the entire data, like phone numbers, email address, or some personal data. So there are some laws and limitations for data. Even though in India, recent times we are seeing mask brothers where we will be masking our Aadhaar number except for last 4 digits. So that is data masking. So we need to create that data masking and monitoring. So we need to monitor continuously whether it can be our jobs or workflows, orchestrated workflows or anything. We need to monitor it continuously so that if any failures or if anything happens, um, we'll be knowing it immediately. If something is down, we need to do the workaround for it and bring it back up. So everything we need to monitor. So even for that also we have CloudWatch to monitor the logs and to see whether something is down or something is happening there. We can create alarms or notifications. We can do lot many things in cloud for all these purposes. So there are few scenarios where we will be having a lot of confusion on data, which is nothing but data swamp or data chaos. So to avoid that, we need to follow few steps. As we are discussing, it is big data. So big data, we'll be getting data in every day. The incoming data may be in GBs. Whether it can be MBs today, it might increase to GB or TB tomorrow, or maybe sometime later. So once the data size is getting increased, it will be difficult to handle that data. So for that reason, uh, when we are querying that much of data, or when we are utilizing that much data, there is lot of confusion will happen for sure. So for that, we need to maintain that data classification or and implement data catalog. So data catalog is nothing but it's like maintaining the metadata. So which is having which kind of data, where we need to store this data, and which data goes into which folder. This kind of catalog we need to maintain. And even data classification is will be done when we are doing with data catalog. So whoever doing this data catalog should take the ownership of the entire data set, and we need to maintain the data quality. So if the data is not proper, when some analyst while analyzing the data, if they are going to read what this record is having, data is not proper, then that might confuse the end users. And security, we need, again, everywhere we go, we need to implement security, because there are potential threats out there in the real-time world, where they will be doing some, might be, it can be unauthorized access, it can be something like that, misuses, using unauthorizedly using accessing the data and for personal use or like their own purpose. So that we need to avoid. So we don't know who is going to even someone who is having a direct access can misuse it. So we need to have some security measures in place to protect the data and so to avoid all these chaos, to maintain all these ownerships, quality, securities in future, we'll be having some creating some manuals or documents or user trainings so that whenever a new data engineer is on board, you need to follow all the steps. You need to take the ownership. You need to maintain the data quality. You need to maintain that security. So in order to do that, we'll be having some user trainings provided. Um, so that's how we are going to onboard data engineers into a particular project to use the data and all. And going, this is the high level discussion about what is data engineering, what a data engineer will do, what is cloud, and what we are going to do with the cloud as a data engineer, and what do we need to do with the data as a data engineer. So this is just a high level. Going forward, we'll be discussing about each and every service in AWS cloud in depth. So now, as we have only 20 minutes time left, so I would like to have questions from you or doubts from you so that we can plan the further sessions.